All right. Well, thank you. Thank you all for staying around. I realize I'm the last thing keeping you from dinner after a long day of a lot of talks. So I really appreciate your time, but I promise I will make it worthwhile. I also do want to thank all of our sponsors for this event, and in particular, Conductor. Conductor is one of our sponsors for this, and they provide a solution built on top of Apache Kafka. So I think that's probably something a lot of you use. If you're doing distributed event sourcing, that's probably what you're using. And it can be great itself, but it can also introduce some complexities. So I think something that makes that simpler is probably something that would be of value to a lot of people. And I know they are also hiring functional Scala and ZIO developers. So I was definitely in the situation once of looking for a job. And I think if anyone else either here or remotely is, definitely something to check out. But with that, let's dive into our topic for the day, which is scopes. And so as John said, we explored this idea of could we actually have specific types that would indicate which resources you were using and which resources had been opened and not closed yet. And we found there was not an actual way to do that in Scala. But along the way, we got thinking about scopes. And so I want to walk you through some of that thinking and where we got to from there. So I'm going to proceed in 3 parts. First, we're going to talk about managed resources and how managed resources are represented in ZIO today. And then we're going to talk about this concept of scopes, what scopes mean, how they actually existed in ZIO 1, even though maybe we didn't always use that terminology. And then we're going to talk about what it would mean to take these scopes and actually make them first-class values, make them normal objects that we can deal with, and where that takes us. So to start out, in ZIO right now, the way that we would represent managed resources is with this data type called a zmanaged. And so this zmanaged is very similar to a ZIO. It has the same REA, but its defining feature is this use operator here. And we can think of this zmanaged as describing some kind of resource that requires finalization. So it's going to produce an A, and that A eventually has to be released somehow. And what this use operator guarantees is that we can do something with that A value. Maybe this is producing a file. We can do something with that file. And as soon as this thing we're doing with it is done, whether it succeeds, whether it fails, whether it's interrupted, that resource is going to be closed. And so it's defining constructor is this acquire release with, or in ZIO 1.0 it would be make, which just says, well, give me the acquire action, give me what you need to open the file, to open the socket connection, and give me the release action. Tell me what I need to do to close this thing. And I'll put those together into this zmanaged data type. And so there are a lot of nice things about this zmanaged data type. And we'll go through each of these in a little more detail. But it gives us resource safety in the presence of asynchronous code. It lets us separate the description of a resource from how it's used. And it gives us a place to put operators for working with these resources. So let's look at each of those. So the first one, and maybe the most important fundamental one, is it gives us resource safety in the presence of concurrency. And so I've got a simple example here that doesn't use zmanaged right now. And so what I'm doing here is I'm opening a file. And then once I've got that file, I'm going to use this useFile method, which maybe is going to read all the contents of this file. And I'm using the ensuring operator to say, well, when I'm done with using the file, whether that succeeds or fails, make sure you go and close the file. And depending on how much you look at this stuff, you might not realize this when you look at it, but this right now is not resource safe because I could get interrupted between these two lines of this for comprehension. And the guarantee of ensuring is only that if this use file starts executing, then I'm going to run this finalizer. But if I get interrupted between these two things, then this finalizer is never going to run, and I'm going to leak this resource. And if I want to fix that myself, I have to do some pretty tricky things. I have to use operators that I don't know if any of you have used, like uninterruptable mask, that really requires me to take responsibility for like exactly where I'm allowing interruption and exactly where I'm not allowing interruption. And it's very easy for me to get that wrong in one way or another of either allowing interruption where I shouldn't, and then I create code that's not resource safe, like this code here, or making too much uninterruptible and actually creating code where I can't interrupt it when I really want to be able to interrupt it. When that's one of the great properties of ZIO that we want is as soon as we determine that something's not needed, we can just stop doing it and stop wasting any more time on it. And zmanage just takes care of all of this for us. As long as I use zmanaged and I don't do anything crazy of like trying to kind of dig into the zmanage myself and separate those acquire and release actions, I never have to worry about resource safety concerns. I just use the zmanaged and I'm done with it. So that's all great. Another really nice thing about zmanaged, a little more conceptual, is this idea that it lets us separate the description of the resource from how it's used. So if we think about a simple example where maybe we're working with files here, and we've got this file operator that's just going to take the name of a file. Maybe it would take a path as well instead. And it's just going to return us this zmanaged that gives us a handle on that file so we can do something with it. And then someone else is going to come along and they're going to call that, and then they're going to use this use operator and they're going to do something with the file handle. They're going to read the contents. And the really nice conceptual thing about zmanaged is two different people or two different teams even can do each of those things, and neither of them have to know anything about what the other person is doing. So someone can say, well, I really know about files, or I really know about socket connections, or whatever resource you have. And I know how to open them. I know how to close them. I don't know anything about what you want to do with them, but I know how to open them and close them. And then someone else can come along and say, well, I want to do something with that. I have no idea how to open it. I have no idea how to close it. I don't really know any of that stuff. I just want to use it. And those can be two completely separate groups of people, and they can both go about their lives happily, not knowing anything more about each other. And then the third thing that we get from zmanage that's really nice is we get this ability to compose resources. So if we just have that zmanage and we just have that acquire release with constructor that just lets us build one, well, that's great if we have one file, but what if I need to work with two files? What if I need to read from one and write to the other? And one of the really nice things that zmanage gives us is the ability to compose these resources together to build more complex resources that say, well, maybe I need a resource that represents both of those files. And that's really easy with zmanage because we just use flat map on it. And we can just do a for comprehension like this. And this is going to return us a new zmanaged value that now represents acquiring both of those files and then safely releasing them when we're done with them. And we get very specific guarantees around how that's going to work, that not only do we have this resource that describes two files, but at least in this case, I'm going to open the first file, then I'm going to open the second file, then I'm going to close the second file, and then I'm going to close the first file. And that reverse order of acquisition is actually really important if we have cases where maybe the first resource is like opening a network connection and the second resource is opening some file on a remote server. And if we accidentally close the network connection first, then we no longer have a way to say that we want to close the file on the remote server. And we can have lots of other operators. We can have like zip par on zmanaged that says, well, now I want to acquire these resources in parallel and I want to release them in parallel. And we can have lots of other operators on zmanaged. So all of those things are great. What are some things that are not as great? Well, I think we could, again, put them into maybe three categories. We'll talk about each of these a little bit more. One is it's just one more data type. One is we end up missing operators on that zmanaged data type. And the third is we just have a proliferation of operators here. So let's look at each of those. So the first problem is just, and this goes back a little bit to my talk at Functional Scala last year, it's one more thing that you need to learn about. So you've had to learn about ZIO, you've learned your whole concept of the environment type, your errors, you've learned all about that. You're doing whatever else you're doing with GraphQL, with Pulsar, with Apache Kafka, with whatever you're doing. And now we're saying, okay, well, here's this other thing you need to learn. You need to learn about the zmanage thing. And I think as a result, like, there's actually a good number of people I see who they never use zmanaged. Maybe they use that acquire release with, or in ZIO 1.0 it was called bracket operator on like a specific ZIO to describe one resource that they just want to use at that time, but they never use that zmanaged data type. And then it just creates this question of like, well, when do I use a ZIO versus when do I use a zmanaged? And sometimes I see this pattern where kind of your whole program becomes a zmanaged, because once you have a zmanaged one place, it kind of proliferates to every place else unless you have very well-defined semantics of like, okay, I want to use this resource in this place. And so we end up, even in ZIO 1, we had a like managed app data type that essentially your whole app was just a zmanaged. The second thing is we ended up having missing operators on zmanaged. So I think one of the design goals was that it should have essentially all of the operators that were on ZIO, with the exceptions for ones that maybe were very low level that didn't make sense. But I think when you don't actually have a way to enforce that with like your type system in code, when that's just an intent, it's easy for that to not happen. And so you can have some surprising cases that you run into, where, for example, if you want to flat map a resource, that's great. If you want to zip par a resource, that's great. Right now, you can't race two resources. That operator doesn't exist. If you want to control the interruptibility of a zmanage, that operator doesn't exist. There are a bunch of cases like that that you can kind of run into. And you can say, okay, well, we should go and we should implement that particular one or this particular one. But that's a little bit treating maybe the symptom versus the disease, that like, as long as these are just two completely different things, you're always going to have some divergence between them as operators get added to one versus the other. And then the final thing is we just end up having a lot of managed suffix variants. So if you think about like, okay, now we got the zmanaged thing. Now basically every other data type we have anywhere, whether that's in ZIO or whether that's in ZIO ecosystem libraries, that represent some type of effect, whether it's like HTTP that represents a HTTP request that can return an effect. Any of those needs to have constructors to take a managed resource and convert it into that thing. And then any of those things that we can run to execute them back to a ZIO value needs to have variants that are going to return a managed. And so if you look at the API of ZStream, for example, there are all these run methods. And every one has well, maybe if there are 10 run methods, every one has a run and a run managed variant. Or there's like a fold and fold managed, fold while managed, fold while ZIO managed. You have a proliferation of all of these different variants to do these things. And then you also see that in things like the toManaged operator. So toManaged just takes a ZIO and converts it into a zmanaged. And if you work with code where you have a lot of managed values, one of the things we end up telling you is, well, the way you make your for comprehension work, because your for comprehension has to all have the same data type for everything in the for comprehension, is turn it all into a managed. And so you have some for comprehension that maybe has 6 lines. One of them is actually a managed resource. The others are just ZIO values. Every one of those lines has a toManaged. And you can say, well, maybe we don't need all that. So okay, that's zmanaged. I think that's, at least from my perspective, a fair summary of both what's great about it as well as what's not so great about it. So now let's step back a little bit and think about this concept of scopes. And so this idea of scopes has actually been around in ZIO since really before ZIO 1.0. And you can think about it as applying to any of what we sometimes call regional settings. So like the interruptibility of an effect, the thread pool you ran on, or even the way that FiberRefs worked, where you could locally modify a FiberRef. And so let's look at some examples of that. So in ZIO, you can control whether an effect is interruptible or not with these operators that have the very straightforward names of interruptible and uninterruptible. And so here we've got this code block where I'm putting uninterruptible around this whole thing, and then I'm doing the first thing. Then I'm putting interruptible around this block, doing a second thing. Then I'm putting uninterruptible around this block and doing the third thing. Then I exit this block, I do the fourth. I exit this block, I do the fifth thing. And this actually has extremely well-defined semantics, where we would say inner scopes take precedence over outer scopes, which you could think of as exactly the same thing of if you're just doing normal programming and you have val x in one scope, and then you shadow it and you define val x in an inner scope. The x you define in the inner scope takes precedence over the outer scope. And so here, this is going to be uninterruptible. This is going to be interruptible. This is going to be uninterruptible again. This is going to be interruptible again. And this is going to be uninterruptible again. And if you're familiar with ZIO, you could just look at that and you could know that. And that really pays off for you when you learn ZIO because you see that same pattern over and over again. So let's shift domains a little bit from interruptibility to thread pool shifting. So now I've got basically the exact same code, except I've replaced that uninterruptible and interruptible with this onExecutor operator. Or in ZIO 1.0, it would have been called lock. This is the one that says, guarantee that this effect is run on a certain thread pool, and when you're done, shift it back to the original thread pool. And you would get exactly the same behavior here. Of this is going to be run on executor 1, then this is going to be run on executor 2, this is going to be run on executor 3, this is going to come back to executor 2, and this is going to come back to executor 1. And you could get exactly the same thing with FiberRefs. So here we're modifying this FiberRef, which is like a ref type we talked about earlier, which represents some state that can be modified within a certain scope. And so we have exactly the same behavior, that for the purpose of this effect here, the value of this FiberRef that it's going to see is value 1. And this effect is going to see value 2. This effect is going to see value 1 again, value 2, and value 3. So we had this idea of scopes that existed, again, even before 1.0 came out as a final thing, that we said any of these things, they modify this setting, they modify the interruptibility, they modify the thread pool, they modify the value of this ref for a certain scope, and inner scopes override outer ones. And another way that we could think about all of these things we just saw is that all of these represent what we could call static scopes. And that means that we know the beginning and the end of that scope when it's created. So like if I think about this example here, where I do FiberRef.locally, so I'm going to locally set this FiberRef to some new value, and I'm going to do something with it, and then I'm going to flat map, and I'm going to do something else. And so just looking at this code snippet, I know that the scope of this FiberRef being modified is limited to this do something. As soon as I've written this first section of code here, I know that as soon as do something is done, that FiberRef is going to be set back to its original value. And anything else I do, like this flat map and this do something else, by the time I'm starting do something else, that value is going to have been set back to its original value. And if we look at the acquire release operator in ZIO, or what we would have called bracket in ZIO 1.0, we see that it works exactly the same way. So bracket is the operator on ZIO versus zmanaged for dealing with resources. And we see that it has exactly this behavior that as soon as I call this acquire release with, I tell it how to open the file, how to close the file, and what to do with the file. And just by looking at that, I know that the life of the file is limited to this use file operator. As long as this use file workflow is running, the file is going to be open. And as soon as it's done, the file is going to be closed. And once I've called that operator, there's nothing I can do to keep that file open beyond that. That file is going to be closed as soon as use file is done, come hell or high water. And so by the time I do something else, the file's already closed. And so that's why we would say when you're doing something like this, use file always needs to return something that's valid after the file is closed. It needs to actually read the file and return the contents of the string or the length of the file or do something else with the file. And when we look at it this way, we can start to see what is in a way the fundamental aspect of this zmanaged here is that in contrast to all those examples where we had a static scope, where we knew how long it would go, zmanaged creates what we could call a dynamic scope. And so here I've got the same example we looked at before where we're opening two files. I've done it with an actual flat map instead of a for comprehension just to make the similarity between the two examples more apparent. But with zmanaged, when I do that flat map, instead of the flat map occurring after the file's closed, the flat map extends the life of that file. So now this file is not going to be closed here. This file is going to be kept open throughout the scope of all these things that I flat map. Every flat map I do just extends the scope of that. And so when I have a zmanaged, I don't actually know what the scope of that's going to be yet. It's going to depend on what other things I compose with that zmanaged, and then eventually what I use that zmanaged for. Because the life of that file 1 is going to extend through the life of anything else I'm acquiring through other zmanaged values I flat map, as well as anything else I do with that use operator. So okay, so far we've understood a little more about the concept of scopes. We've understood this idea of static versus dynamic scopes. And we've seen how this is actually implicit in all of these things we've seen in ZIO1, in regional settings, in FiberRefs, in managed resources. But one thing I think we could say about ZIO1 is in ZIO1, this concept of scopes was what we could call implicit, not in the implicit versus given Scala 3 sense, but in the sense that it was a concept versus an actual value we could look at. If you ever came on the ZIO Discord and you heard us talking about some of these things, we might use language like it creates a static scope or it creates a dynamic scope. But there's nowhere in the code base that I could point you to where I could say, that's the scope. It's just this like concept that is floating around in our heads. And so the line of thinking that we started to go down as we were exploring this idea of could we represent these resources as types is what would it look like if a scope was a first-class value? And so we can start to think about that by looking at this scope data type here. And so a really simple way we could think of as a scope is a scope is something that we can add finalizers to. Right? We can essentially say, hey, whenever you close this scope, run these finalizers. And you could just add one finalizer after another to the scope. And eventually, you can close the scope. And you can give it some exit value because potentially the finalizer maybe wants to do a different thing if there was a success or a failure or interruption. But eventually, you can close the scope. And then when the scope is closed, it's going to run all of the finalizers that are associated with that scope. That's the simplest concept that we could come up with for a scope. And we could use that to represent all the things we talked about before, where if I want to change some setting and then change it back, well, what that means in terms of scopes is I change the setting and I add a finalizer to my scope that says to change it back. So the next move we can make there is we can think about what happens when we take advantage of having scopes and having the environment. So now we can think about having this file constructor that's going to take a name of a file we want to open. And now it's going to return a ZIO, not a zmanaged. It's going to give us a handle on that file, and it's going to require a scope. And so now the semantics of this are going to be whatever is happening in this question mark is going to open the file, and then add a finalizer to this scope that this thing needs to run that is going to close the file when that scope is closed. And because this thing now has a scope in the environment, we're not going to be able to run this at all until we provide it with a scope. And the way we do that, the way we specify the size of the scope, is with this scoped operator. So this is an operator on ZIO that says, well, give me a workflow that requires a scope as well as some other environment. And I'm going to give you back a new workflow that requires all of that environment, except it doesn't require the scope anymore. And so what I can do then is, if I do file, or I open this file with a path, so this is going to create an effect that depends on a scope, and then I'm going to flat map it. I'm just going to do something else with it. So we know that when we combine different effects that require different environments, we get a new effect that requires all of their environment types. And so this whole thing is going to require a scope. And if we don't do anything about that, we're not going to be able to run that because we need to eliminate that scope in order to actually run this thing. And then when we call this scoped operator, we say, OK, provide it with the scope, let it run, and then close the scope as soon as we're done with it. And so this we could think of as being analogous to the use on the zmanaged. And so what we see there, if we look at that example a little more, is that this scope data type lets us describe these scopes that are dynamic. So if I do this file path that creates something that depends on a scope, I can flat map that, and I can do something with it, and I've got a new effect that still requires that scope and isn't going to close the scope yet. And I can flat map it as many times as I want. I can do as many things as I want with it, and that scope is going to stay open, and it's going to get bigger and bigger and bigger. I'm just going to use more things with the file. And it's not until eventually, whenever I want to say, OK, I'm done working with this file, I've done the work I want to do with it, that I call this scoped operator, that I say, OK, now I know the boundaries of this. Now I know when I'm opening this, and I know exactly when I'm closing it. And anything I do after this, any flat map that I do down here, I know by that point the file's already been closed. And so then we could say, OK, so these scopes describe dynamic scopes. But we also said earlier that the whole point of zmanaged, what made a zmanaged different than a ZIO value, is that it was a dynamic scope versus a static one. So if we can already represent dynamic scopes just with ZIO in the environment and this very simple scope data type, then we actually don't need zmanaged at all. And let me unpack that a little bit. So I know that's a little bit of a bold statement. That's a core data type in ZIO. So is that really true? Can we really get rid of zmanaged here? And let's go back and let's revisit. We, I think, did a fair inventory at the beginning of what were the advantages and the disadvantages of this zmanaged data type. So now that we've got this scope thing and we've got this concept of the scope in the environment, how does that stack up? So the first thing we said we liked was we liked the fact that we had this resource safety in the presence of asynchronous code. And so let's look at that. Let's go back to this. This would be kind of the prototypical example of using a file and doing something with it. Right? Maybe we're going to open the file here, and we're going to read its contents as a string. And what we see is this code here provides exactly the same guarantees of resource safety as the version where we use zmanaged and we called use on the zmanaged. We still have the exact same guarantee that we're going to create a scope here. We're going to try to do this thing. And if this successfully opens the file, then no matter what happens after that file has been opened, whether it's interrupted immediately after that, whether it starts executing use and use is interrupted, whether use succeeds, whether use fails, no matter which of those things happens, that file is still going to be closed as soon as this stops executing. So this is literally the same guarantees of resource safety that we have for zmanaged. We can take all the tests that we have, we can rewrite them in terms of this, and they have exactly the same properties. So second concept, we said we really like this idea that zmanaged lets us separate the description of the resource from how it's used. Can we do the same thing here? The answer is yes. So again, we have this file constructor that is going to take the name or the path of the file we want to open and is going to return a handle for this file and is going to require a scope. And this, once again, it knows everything about what we have to do to open and close this file, because this implementation is going to open the file and it's going to add a finalizer to the scope that's going to close the file. And it doesn't know anything about how we're going to use the file. All it knows about is the concept of this resource, of opening and closing the file. And then someone else is going to come along, and they're going to do whatever they want with the file. They're going to flat map it as many times as they want. And when they're done with using that file, and we want to close that scope, they're just going to call the ZIO scoped operator. And they're not going to need to know anything about how they open these files, how you close them. They're just going to know what they want to do with the file. So again, we get that exact same separation between the description of the resource and the description of what we want to do with it. And then let's look at composing them. So this is, I think, one of the biggest bulbs that went off in our head as we did this, is when you compose these ZIO values that depend on a scope, things happen incredibly naturally, and you just get what you would expect. So here, I'm now doing a for comprehension with my new file method that returns a ZIO that depends on a scope. And so this is no longer some different special flat map on zmanaged. This is the exact same flat map on ZIO that we use every day, and I haven't made any changes to it. And this is going to get us the exact behavior that we want for these two resources. Because when I run this, it's going to add the finalizer that closes path 1 to the scope. And when I run this, it's going to add the finalizer that closes the second file to the scope. And so I'm going to get a new thing that has new scope that has two finalizers in it. And the rule for these scopes, by default, is when I close them, they run the finalizers in the reverse order of acquisition, just like we said makes sense because of that example we had first we were opening the remote connection, then we were opening the file on the remote server. So this already does the right thing. Like if you go back to especially like earlier versions of ZIO 1, the implementation of flat map on zmanaged is like pretty complicated. There's a lot going on there. And you could say the same thing for a lot of other zmanaged operators. Versus this, like literally just works as written. And I can implement a ton of operators that way or with very minor changes. So zip par, right, acquiring two resources in parallel. That was another implementation that used to be super complex. The way I acquire two resources now, well, I do file path 1, zip par, file path 2. And it's just the same zip par that we already have on ZIO that we use all the time anytime we want to do any parallelism. And then I just have to use one other operator that tells this scope, hey, I want to release these resources in parallel instead of sequentially. Because if we're saying we require them parallel, we'll release them in parallel as well. And if I want to race them, well, I can race them by racing the two ZIOs. And I don't need some new complex implementation. I just use the existing implementation I have. So we get all the things that we said we liked about zmanaged with this concept of scopes. So how about the things we didn't like? Well, we don't have one more data type anymore, right? We get to delete that zmanaged data type. we don't have to worry about missing operators anymore, because now there is only one data type. There is only ZIO. And so every operator that's defined on ZIO already exists on a ZIO that requires a scope, just like it exists on a ZIO that requires a console or a ZIO that requires a random service. And we also get to get rid of a lot of these variants. So now there's just this one thing. I never need to call toManaged to convert a ZIO to a zManaged, because anytime I want to, we know I can always compose things that require different environments, and I just get the combination of them. So if I combine a ZIO that doesn't require a scope with a ZIO that does require a scope, well, I'm just going to get a new ZIO that does require a scope. And I don't need separate operators to do that. And similarly, I don't necessarily need separate operators to run everything to a zManaged versus to a ZIO. Because I can always, anytime I've got something that requires a scope, I can just do ZIO.scoped and put that around there and eliminate that. And that is going to apply not only to ZIO Core, but also to all of these ZIO ecosystem libraries. If I'm an author of ZIO Query, or if I'm an author of ZIO HTTP, before I needed to maybe both deal with, to be able to take in all these different data types, both a ZIO and a zManaged. Maybe I also need to support running these things to a ZIO and a zManaged. Maybe I needed to support various transformations of like, do I want to do a map ZIO? Do I want to do a map with a managed? I can come up with all these things. Now we've got one thing. Right? It's back to that idea of dissolution versus a solution. So what's the path forward from here? So I've got a PR that is ready to go that deletes zManaged from both ZIO Core and ZIO Streams. Everything in, as well as ZIO Test. I guess that's a little less exciting, but that too, because we also got to be able to test everything. So deletes zManaged from all of those, re-implements all of that functionality in terms of these scopes. And obviously we want to be, we don't want to make everyone change right away, even though we think this is better in the future. So there's going to be a new ZIO.managed package, just like ZIO.stream. That will be a separate dependency you can pull in if you want to, and is going to give you both that zManaged data type as well as all those operators that you might work with as extension methods to work with that. So if you're like, hey, I've liked my zManaged operators, I want to kind of keep doing things that way, great, it's still going to be there for you. But we think that as we go forward, this concept of scopes is going to provide a much more, in a way, lightweight way of working with resources. Where I think one of the problems with zManaged was it was just pretty heavyweight in that any time you wanted to switch from not using resources to using resources, you had to bring in a whole completely new data type. And you could almost think about it as like, what if the same thing was true for like errors? What if we said, anytime you want to use errors, then don't use ZIO, use errorful ZIO or something, right? Like we would say, no, that's like terrible, right? Or the environment type. But that's a little bit like what we've had with resources. And I think in some ways it's actually pushed other design decisions to maybe not be as ideal. So for example, if you've worked with fibers, you might have gotten bitten at some point by some of these concepts of fiber lifetimes. And there are some operators that deal with fiber lifetimes in ZIO that are probably some of the most complex operators in ZIO. When I was writing Zionomicon, I was doing the chapter on those operators about transplanting the fiber scope from one to the other. Those are some of the most tricky things. And luckily, you almost never have to deal with them yourself. But that's something where another way you could think about it that we intentionally didn't do in ZIO 1.0 is you could have said, well, every fiber should be a managed resource, right? When you're forking something, you're essentially allocating resources that are associated with that fiber, have some lifetime, and you should specify somewhere when that fiber should get terminated. Now, we didn't do that because we felt like that would be unergonomic. It would not be very nice if every time you forked something, you got a zManaged, or basically just force like everything in the world to be a zManaged, and that would not be great. But now, that's something we could potentially think about. Right now, it could potentially just give you a scope. And one of the great things about these scopes is you can always just push them higher and higher. So ideally, of course, you would close everything at as narrow a scope as you could. You could say, like, literally, as soon as I'm done with this file, then close that file. But you could also say, well, look, that's all great, but at least for my application, anything I haven't closed previously, close at the scope of the whole application. So big change, but going to do it in a way that, again, supports you if you like ZManage and want to continue using it. And I think is going to really be a radical simplification that's going to take one of the core data types out of ZIO and let us work with resources in a much simpler way. And just another reflection of this idea, we're always looking to simplify. We don't want there to be any reason for you to be afraid of taking advantage of resources. Right? One of the things we've heard is some people just aren't using ZManage because it's another data type, because they're like, well, when do I use that? How do I use that? And so they just don't use it. We don't want people to be afraid of that. Like, use your resources. It's just going to introduce this type in the environment, and you can always just close those scopes. And I think particularly as we get to these ZIO ecosystem libraries, it's going to be a really nice simplification of just having one fewer core data type that they need to deal with. So with that, I'd like to do a bunch of thank yous here, particularly to John and Sandra, my co-founders here. John's been a real mentor to me, and Sandra does a ton of stuff to both make this event happen as well as make everything we do at Ziverge happen. So I want to thank them as well as all of my colleagues at Ziverge. I think you've heard from a ton of them today, a ton of really impressive talks. So I feel very, very lucky to be able to work with such a talented group of people, as well as all of the ZIO contributors and users, many of whom are lucky to be. I'm lucky to have you here today, either here in person or remotely. And then finally, our conference sponsors who make this possible. Obviously, for us to come to a nice event like this and have a nice room like this and food and drinks, there's a cost for that, and they make that possible. And for all of you who are here or remote. So thank you so much, and I'm really excited. This is basically ready to go, so as soon as we're done with this and maybe done with drinking and I have a chance to copy and paste everything over, we'll get a first version of this out, and we'll definitely have iterations on that as we kind of iron things out. But again, we've got literally every test in the ZIO test suite passing with no more ZManage. So yeah, very excited about this. Thank you so much.
Thank you.